Hi guys! Welcome sa ENGINerdmath channel. Sa video na to ay magre-review tayo for Engineering Sciences Board Exam which is GEAS or ESAS for Engineering Mechanics Statics. So kung gusto nyo itong matutunan, just keep on watching. Okay, so this time ay magre-review ulit tayo for Engineering Board Exam Review which is GEAS or ESAS. Ang specific topic is Engineering Mechanics Statics. So, magsasagot ulit tayo ng sets of questions. Let's start with question number 1. Determine the resultant of the following coplanar forces: 90 pounds to 110 degree, 130 pounds to 160 degree, 15 pounds 30 degree, and 55 pounds 80 degree. Okay, so meron daw tayong given na 4 coplanar forces. Hanapin daw natin yung resultant nila. Okay, so pag maghanap tayo ng resultant ng forces, pwede natin gamitin yung analytic method. That is, isasum up natin yung horizontal at vertical components nila. Okay, so para magawa yun, para ma-visualize natin yung position ng mga forces natin, isi-graph natin yung mga forces sa rectangular coordinate system. Okay, so draw tayo ng rectangular coordinate system. So, kapag nagpa-plot tayo ng force sa rectangular coordinate system, meron tayong conventions. So, yung angle natin, laging nagsa-start sa positive x-axis. And then, yung rotation natin kapag counterclockwise, positive angle, which is yun yung usually ginagawa natin. So, kung i-consider natin itong 90 pounds to 110 degree, magsa-start tayo sa initial side na positive x-axis, then magro-rotate tayo counterclockwise to 110 degree. So, obviously, approximately nandito siya sa third quadrant, right? Kasi this one is 90, this is 180. So, lagpas ng onte sa 180. So, this is approximately the 90 pounds force. So, yung magnitude niya is 90 pounds. So, this is 210 degrees from the positive x-axis. Or usually, ang ginagawa natin is kinukuha lang natin yung acute angle nitong 90 pounds force doon with respect doon sa horizontal axis. So, alam natin na ito is 180 na, right? So, ang total niya is 210. So, ilan pa dapat itong acute angle? 30 degree. So, pwede natin i-represent yung 90 pound force as a force vector that lies on the third quadrant with 30 degree angle with respect doon sa horizontal axis. Pero dapat mamaya iti-take note na natin yung sign convention. Okay? So mamaya discuss natin. Next, para sa 130 pounds to 160 degree, ganun ulit, rotate tayo ng 260, so lagpas siya ng onte sa 210. So medyo mas malaki yung acute angle niya, so approximately let's say dito. Okay? So, ito ay 130 pounds. So, dapat, kung ito is 180, ilan pa yung kulang para maging 260? Itong angle na to dapat is 80 degree. Okay? So, this one is 30, this one is 80. Okay? And then, for 15 pounds, 30 degree, so, nasa first quadrant lang siya kasi 30 degree lang. So, approximately nandito. Okay? 15 pounds, 30 degree. And then lastly, yung 55 pounds, 80 degree. So, mas malaki lang ng onte sa 30 degree, approximately nandito. Okay, magnitude is 55 pounds. Then this angle is 80 degree. Okay. Ngayon, na-plot na natin. Isasum up na natin yung horizontal at vertical component. Yung horizontal component, summation along x-axis. And yung vertical component summation along y-axis. So, lagi kapag kinonsider natin is with reference sa horizontal axis yung ating mga angle, meron tayong formula for the vertical and horizontal components ng force. So, yung horizontal components, let's say f sub x is equal dun sa magnitude ng force times cosine nung angle niya. Then, yung vertical component niya, f sub y, is equal naman sa magnitude ng force times sine nung angle niya. Okay? So, pag sinamap natin, let's say, yung x component muna. So, dito muna tayo sa 15 pounds. So, using this formula, magnitude niya is 15. Then, cosine nung angle niya na 30 degree. So, take note, may sign convention tayo. Kapag yung terminal side ng force is nasa first quadrant tsaka fourth quadrant, yung horizontal component is positive. Then kapag nasa second or third quadrant, negative naman yung ating horizontal components. Okay? So, positive 15 cosine 30 degree. Then dito sa 55 pounds, positive din siya kasi nasa first quadrant yung terminal side. So, plus 55, then cosine nung angle niya na 80 degree. Then para sa 90 pounds, so dahil nasa third quadrant siya, minus, right? Minus 90 cosine ng angle niya na 30 degree. And then lastly, itong 130 pound, 80 degree, nasa third quadrant din, so minus. Minus 130 cosine 80 degree. So pag sinolve natin to using calculator, ang masasolve natin is approximately negative 77.975 pounds. Okay? Then, doing the same, dito naman sa summation ng forces along y-axis, this time ang formula naman natin is ito. Okay? Ngayon, meron ding sign convention sa vertical component. So, kapag nasa first at second quadrant, yung terminal side ng force, positive yung kanyang value. So, positive, positive. And then, kapag nasa third at fourth quadrant, yung vertical component naman is negative at negative. Okay? So, para dito sa 15 pound, sa formula, magnitude 15 times sine nung angle niya na 30 degree. So, positive siya kasi nasa first quadrant. Same dito sa 55 pound, positive 55 sine 80 degree. Then, para dito sa 90 pound, nasa third quadrant siya, so minus. Minus 90 sine 30 degree. And then, ito rin yung 130 pound, negative 130 sine 80 degree. So again, pag kinompute natin to sa calcu, ang masasolve nating value is approximately negative 11.36 pound. Okay? Ngayon, hindi pa tayo tapos kasi ang magiging final answer dapat natin is gagamit pa tayo ng Pythagorean theorem. So, yung pinaka-resultant natin is square root nung summation ng force along x squared plus summation of force along y squared. So, pag kinuha natin yan, we have square root of, yung summation ng fx natin is negative 77.975 squared, plus summation ng y natin is negative 111.36 squared. So, using calculator, ano yung resultant natin? So, approximately 135.94 pounds. Ngayon, meron din dapat tong direction. So, mapapansin nyo, meron tayong negative na horizontal component tsaka negative din na vertical component. So, ibig sabihin, yung pinaka-resultant natin, base sa sign convention natin kanina, parehong negative, right? It falls under third quadrant. Okay? So, nasa third quadrant yung resultant, yung magnitude niya is itong value ng R na 135.94 pounds. And then, kukuhain natin tong angle na to with respect dito sa horizontal axis or x-axis. Ang formula is arctan. So, this one is the theta. Ang absolute value, yung na-compute natin na summation of x saka summation of y, summation of fy over summation of fx. So, equal yun saan? Arctan of absolute value of yung summation of fy is negative 11.36 and then yung summation ng fx is negative 77.975. So, using calculator, approximately ilan yan? 55 degree. So, this theta is 55 degree. So, kung kukuhain natin yung direction is with reference pa rin dito sa positive x-axis. So, therefore, approximately ilan dapat yan? Mag-a-add tayo ng 180, right? Kasi laging with reference natin is positive x-axis. Since yung terminal side niya is nasa third quadrant, itong acute angle natin na nakuha, dadagdagan pa natin ng 180. So, therefore, yung final direction niya is 55 degree plus 180 degree is 235 degree. So, therefore, ang sagot is yung resultant R is 135.94 pounds with direction of 235 degree from the positive x-axis. So, the answer is choice B. Next, we have, in the system shown, a 5 kg block rests on a horizontal tabletop with mu sub s, or coefficient of static friction, equal to 0.5 and is attached with the horizontal string to a second string as shown. What is the maximum value for the mass m if the first block is to remain stationary? Okay, so meron tayong given figure dito. So meron tayong dalawang block. Yung isang block, yung 5 kg block, is nagre-rest dito sa horizontal table with coefficient of static friction daw na 0.5. And then yung another block na with mass m unknown, hanapin natin, is sinusupport nung string natin. Yung isa is itong horizontal string na naka-attach dito sa first block. And then yung isang string is naka-incline ng 37 degree with the horizontal. Ano raw yung value ng m na makakapag-remain doon sa first block natin in stationary? So, forces in equilibrium tayo dito. So, pwede natin i-consider yung dalawang free body diagram ng separate block. So, pwede tayo mag-start dito sa 5 kg block. So, pag dinraw natin yan, so ito yung 5 kg block. So, yung weight niya, pwede nating ma-compute using yung formula is mass times acceleration due to gravity. So, lagi kapag yung weight, ang kino-consider natin is downward. So, meron siyang downward force, weight is equal to mg. Tapos, syempre, merong ini-exert yung table na opposite force ito sa weight niya, which is yung tinatawag natin yun na normal. So, upward yung normal force natin. And then, meron siyang nakakonect dito na string, right? Okay, syempre, nag-exert din yun ng force, let's say, tension 1. And then, dahil meron tayong coefficient of static friction na given, meron tayong friction opposite in direction dito sa tension 1 natin, dun sa string. So, yung tension natin lagi is away doon sa point of intersection ng mga forces. So, ang i-assume kong direction lagi ng tension is this time away dito sa point of intersection nila, yung center of gravity nung ating block 1. So, to the right. And then, dahil yung friction is laging nag-o-oppose doon sa force exerted dito sa ating block, ang direction nung frictional force natin, let's say F sub S, is to the left. Okay? So, pag ginraw natin sa rectangular coordinate system, yung free body diagram nitong ating block, so, origin to. So, meron tayong T1 going to the right, then frictional force going to the left, and then meron tayong weight W na equal sa mg, and then normal force and upward. So, pag sinabi natin magre-remain stationary itong block 1, walang motion, or meron tayong equilibrium in the force system. So, pag sinamap natin yung forces along x, dapat 0, and sinamap natin yung forces along y, dapat 0 din. So, pag ginawa natin yon, so, along x muna tayo. So, ang forces lang natin in x direction is T1 and Fs, right? So, assume natin na kapag nasa positive x-axis, positive yung force, so positive T1, and then itong Fs nasa negative x-axis, so negative F sub S, and then equated to 0. So, therefore, T1 is equal to Fs. Okay? Now, for summation of force along y-axis naman, equal 0, meron lang din tayong dalawa. So, positive yung force kapag nasa positive y-axis, so we have N. Then, negative kapag nasa negative y-axis, so minus W or mg, right? Equal 0. So, pwede natin i-transpose itong negative mg sa right, magiging normal force N is equal to mg. Okay? Ngayon, meron tayong formula na yung frictional force F sub S is equal to the coefficient of static friction, mu sub S, times yung normal force. So, pwede nating ma-equate itong T1 equal to Fs equal to yung coefficient of static friction natin. Yung given is 0.5, right? 0.5 times yung normal force, this time in terms of mass times acceleration due to gravity. So, yung mass natin na given sa block is 5 kg, right? So, times 5 kg, then yung acceleration due to gravity is 9.81 meter per second square. So, masasolve natin yung tension 1, this time by multiplying 0.5 times 5 times 9.81. So, ilan to? 24.525 Newton. Okay? Ngayon, gagamitin natin tong tension 1 para naman sa free body diagram nitong block 2. Okay? So, draw ulit tayo. So, let's say ito yung block 2 with unknown mass M. So, meron uli dapat siyang weight na downward acting sa center of gravity. So, weight is mg uli. And then, nakakonect siya sa dalawang string, right? Itong isang string is 37 degree with respect to the horizontal. So, laging tension din yung direction natin away from the point of intersection ng force, tension 2. And then, itong tension 1, itong nakuha natin kanina, yung nakakonect sa 5 kg block, away din. So, tension 1. Which is, nakuha na natin to, right? 24.525 Newton. Okay? So, pag ginraw natin sa rectangular coordinate system din, yung kanyang free body diagram. Okay? So, meron tayong force downward, yung weight niya na mg. Tapos, tension 2, nasa first quadrant. Yung angle niya is 37 degree. And then, yung tension 1 is horizontal force directed in the negative x-axis with value 24.525 Newton. Okay? Ngayon, tulad din sa block 1, dapat nasa equilibrium din yung block 2. Ibig sabihin, summation of forces along x equals 0 and summation of forces along y is equal to 0. So, ibig sabihin, 0 yung resultant ng system. Balance yung system and walang motion. So, therefore, pag ginamit natin yung equation 1, yung summation of forces along x, pwede natin i-consider yung horizontal components ng mga forces na involved. So, itong tension 2, may horizontal component siya na yung formula natin kanina, yung magnitude ng force times cosine ng angle niya. So, nasa first quadrant siya, right? So, dapat positive. So, T2, cosine, 37 degree. And nitong T1, dahil direct siya sa x-axis negative, so pwede natin sulat directly yung magnitude niya na negative 24.525 equal 0. So, pwede natin masolve dito si T2, right? So, T2 cos 37 degree is equal to transpose si 24.525 sa right. Then, divide both sides by cosine 37 degree. So, T2 will be 24.525 divided by cosine 37 degree. So, using calculator, ilan yan? So, T2 is approximately 30.71 Newton. Okay? Ngayon, pag ginamit naman natin yung summation of forces along y equals 0, so summation of forces along y equals 0, yung T2 may vertical component din siya, right? This time, yung formula is T2 sine nung angle niya. So, nasa first quadrant, so positive din siya. And then, itong weight downward directly to the negative y-axis, so pwede natin isulat as simply minus mg equal 0. So, transpose natin sa right si mg, so T2 sine 37 degree is equal to mg. So, ang kailangan natin is itong m. So, divide natin both sides by g. So, masasolve natin si m as T2 sine 37 degree divided by g. So, meron naman tayong value ng T2, right? 30.71 times sine 37 degree over yung acceleration due to gravity na 9.81. So, ang unit natin dito is kilogram. So, ilan yan using calculator? So, approximately 1.88 kilogram. Okay? So, therefore, the answer is letter A. Okay, the closest. Next, we have, given the three-dimensional vectors, vector A equal to I times xy plus j times 2yz plus k times 3xz, and vector B equal to I times yz plus j times 2xz plus k times 3xy, determine the scalar product at the point 1, 2, 3. Okay, so kukuhain daw natin yung value nung scalar product nitong vectors A at B at the point 1, 2, 3. So, apply lang natin yung formula sa dot product na pag nagda-dot product tayo ng dalawang vectors, simply ina-add lang natin yung product nung corresponding I, J, K components nila. So, therefore, ang dot product ng vectors A and B is equal doon sa product ng I components nila, which is yung xy for vector A, and then times sa I component ng vector B na yz, plus yung product din ng J components ng vector A, which is 2yz, times yung J component ng vector B na 2xz, plus yung product nung k-component nung vector A, which is 3xz, times yung k-component nung vector B na 3xy. So, pag minultiply natin, xy times yz is xy squared z, plus product ng 2yz times 2xz is 4xyz squared, plus product ng 3xz times 3xy is 9x squared yz. Okay, so ito yung A dot B in terms of variables x, y, z. So, kailangan natin i-determine yung value nitong dot product at the point 1, 2, 3. So, isa-substitute natin sa value ng x is 1, sa value ng y is 2, tapos value ng z is 3 dito sa A dot B natin na nakuha. So, therefore, A dot B at 1, 2, 3 will be 1 times 2 squared times 3 plus 4 times 1 times 2 times 3 squared plus 9 times 1 squared times 2 times 3. So, using calculator to compute this value, ang masasolve natin is 138. So, therefore, the dot product of A and B at 1, 2, 3 is 138. Letter B. Next, we have a 100 kilogram weight rests on a 30-degree inclined plane. Neglecting friction, how much pull must one exert to bring the weight up the plane? Okay, so draw natin yung figure. Meron daw tayong 100 kilogram weight na nagre-rest dito sa inclined plane. Yung angle ng inclined plane is 30 degree. So, let's say ito yung ating 100 kilogram weight. So, directly downward yung kanyang weight is equal dapat lagi sa product ng mass times acceleration due to gravity, right? Ngayon, ang tanong is, neglecting friction, how much pull must one exert to bring the weight up the plane? Okay, so kung wala kasi tayong pull na gagawin dito, pataas, dito sa weight, ang tendency is mag-i-slide down siya, right? So, para hindi siya mag-slide down, or ma-prevent yung pag-slide down nga dun sa plane, ma-prevent siya sa position na to, kailangan nating mag-exert dito ng force P in this direction. Unknown, yun yung hahanapin natin. So, paano natin mahahanap yun? So, take note, wala daw tayong friction. Okay, usually kasi, meron tayong friction dito sa ating surface. Pero, neglecting daw yung friction. So, gawa lang tayo ng free body diagram. So, pwede tayong gumamit dito ng rotation of axis. So, instead na yung conventional axis natin is ganito, pwede natin gawin is i-rotate natin itong x and y axis in such a way na itong P force is nagko-coincide dito sa positive x-axis. So, pag ginawa natin yon, ganito yung magiging itsura. Okay, so dito yung x-axis, dito yung y-axis. And then, kung mapapansin nyo, itong weight natin downward, with respect sa horizontal axis, is nagkaroon na siya ng angle, right? So, let's say, ito yung angle na yon, theta. So, anong theta na to? Equal siya doon sa complement nitong ating 30-degree inclined angle. So, ibig sabihin, complement ng 30 is 90 minus 30 is 60. So, yung theta natin dito with respect sa horizontal axis is 60. Okay, so this is 60 degree. Okay, so i-redraw natin. Sige. Y and X axis. So, ito yung weight natin. So, sabi ko, itong angle na to with respect sa horizontal axis is 60 degree. And then, yung weight is equal to mg. Tapos, itong kino-inside natin yung force P na hanapin natin sa positive x-axis. Okay? So, pwede natin i-apply dito yung condition of equilibrium. So, mag-summation of forces tayo along x dapat equal 0. And then, summation of force along y dapat equal 0. So, by the way, meron pa pala tayo dapat reaction dito sa incline tsaka dun sa mismong body, which is yung normal force. So, upward siya. So, nandito siya sa positive y-axis. Okay? Ngayon, mag-sum up tayo ng forces dito sa x-axis. Kasi, etong P natin is along the x-axis, right? So, pag sinamap natin yung forces na yun, masasolve natin agad si P. So, positive si P kasi nasa positive x-axis. And then, minus itong x component nitong weight natin na mg. Formula natin kanina is yung magnitude ng force, W times yung cosine ng angle with respect dun sa horizontal axis, which is 60 degree. So, minus siya kasi nasa fourth quadrant siya, right? So, negative yung kanyang value. Okay, base dun sa sign convention natin kanina. So, wala na tayong horizontal component na force, so equate na natin sa 0. So, therefore, pag sinolve natin yung P, transpose lang natin itong W cos 60 degree sa right. So, magiging P is equal to W cos 60 degree. Pero natin yung W is equal to mg. So, mg cosine 60 degree. Right? So, meron tayong given na mass na 100 kg doon sa ating body. So, substitute 100 kg times yung acceleration due to gravity natin is 9.81 meter per second squared, constant yon, times cosine 60 degree. So, using calculator, input natin yung values. 100 times 9.81 times cosine 60 degree is what? 490.5 Newton. So, therefore, the answer is letter D. Okay? Next, we have a beam is loaded as shown below. Solve for R1 and R2. Okay, so meron tayong figure dito. So, meron daw tayong beam na merong mga loads as shown. So, meron tayong concentrated load 20 kN, tsaka 40 kN. And then, meron tayong distributed load, rectangular distributed load, which is meron siyang value na 20 kN per meter. So, hanapin daw natin yung reaction R1 tsaka R2. So, meron din tayong mga dimensions ng position ng bawat load. Okay? So, kapag meron tayong parallel loads, pwede tayong gumamit ng moment. Okay? So, draw muna natin yung pinaka-final free body diagram nitong ating beam. So, let's say, ito yung beam natin. So, draw natin dito yung reaction R1. Let's say, at point A. Reaction R2, let's say, at point B. So, this is 2 meters, right? This is 4 meters. Now, itong 20 kN nandito sa dulo, 20 kN. And then, itong 40 kN, from point A, meron siyang distance na 2 meter. Then, dito siya naka-position. Okay? And then, itong distributed load, kailangan nating i-convert into a single concentrated load. So, kapag meron tayong rectangular distributed load, i-multiply lang natin yung kanyang value na 20 kN per meter sa length nitong kabuang beam, which is 2 meter plus 4 meter is 6, right? 6 meter. So, ilan yan? 20 kN per meter times 6 meter is cancel yung meter. So, 20 times 6 is 120 kN. And then, yung position ng concentrated load na yon is lagi sa center ng ating beam. So, since meron tayong total length ng beam na 6, right? 2 plus 4 is 6. Kalahati nun, yun yung center, which is 3. So, let's say around here. Okay? So, this is 120 kN. Concentrated load na ngayon siya. So, from point A, dapat meron siyang 1 meter length. Kasi 2 meter plus 1 meter is 3 meters. Okay? Sa center ng beam. Ngayon, gagamit na tayo dito ng moment. So, pwede tayong mag-moment sa isang point kung saan may makakancel na unknown. So, let's say, mag-moment tayo sa point B. So, kapag nag-moment tayo sa point B, makakancel natin yung reaction R2 kasi yung line of action niya is along doon sa moment center. So, pag nag-summation tayo ng moment at B equal 0, so, ina-assume natin dito na yung ating system is in equilibrium. Okay? So, pwede tayong mag-assign ng sign convention. Let's say positive kapag clockwise yung ating moment. So, yung formula natin ng moment is equal to force times distance, right? So, pag nag-sum tayo ng moment, so, consider muna natin itong 20 kN. So, force times distance, so 20 kN times yung distance niya from moment center B is ilan? 2 plus 4, right? Or 6. So, anong sign? So, itong downward 20 kN force is nagte-tend mag-rotate counter-clockwise, right? So, therefore, negative siya. Kasi yung sign natin is positive kapag clockwise. Okay? Ano pa? Itong 120 kN downward din. So, ibig sabihin, counterclockwise din yung rotation niya, so minus, yung magnitude niya, 120 kN times yung moment arm, yung D. Ilan yung distance niya mula dito sa point B? So remember, nasa center yung 120 kN, right? So therefore, ito ay 3, right? So times 3, and then itong 40 kN downward din, so counterclockwise din yung moment niya. So minus 40 kN times ilan naman yung distance niya dito sa B. So this is 4, and this is 2. So, ilan na lang to? 2, right? So, yung distance ng 40 kN from point B is 2. And then, lastly, yung unknown, yung R1. So, 4 meters siya from point B. So, yung unknown R1, by the way, anong sign niya? Upward siya. So, magti-tend siya mag-rotate, this time clockwise. So, positive. Unknown R1 times yung moment arm, distance ng R1 from point B is itong 4 meters. Okay? Sige, 4 na lang. Equal 0. So, solving for R1, R1 is equal to what? So, transpose this term sa right side, then add, then divide both sides by 4. So, R1 will be equal to 140 kN. Okay? Now, si R2, pwede na natin siyang masolve using summation of forces along y-axis or yung vertical components kasi puro vertical lang naman sila, right? Applying din yung condition of equilibrium. So, yung mga upward, positive. So, si R1, nakuha na natin, upward siya. So, positive, which is 140 kN. Si R2, upward, then unknown pa. Then, lahat na ng mga downward force natin is negative. So, minus 20 kN, minus 120 kN, minus 40 kN equals 0. So, solving this equation for R2, ang masasolve natin is R2 is 40 kN. So, therefore, the answer is R1 is 140 kN and R2 is 40 kN. So, nakalimutan natin maglagay ng choices pero ang answer should be R1 is 140 kN and R2 is 40 kN. Okay? Next, let's have some objective type of questions. For 6, we have the moment of inertia of a plane figure, blank. A increases as distance of the axis moves further from the centroid. B is maximum at centroidal axis. C is 0 at the centroidal axis. D decreases as distance of the axis moves further from the centroid. The answer is letter A. Increases as distance of the axis moves further from the centroid. 7. Varignon's theorem is used to determine blank. A. Location of centroid. B. Moment of inertia. C. Mass moment of inertia. D. Moment of area. The answer is letter A. Location of centroid. 8. It shows the forces acting on an isolated object. A. Force diagram. B. Schematic diagram. C. Free body diagram. D. Force polygon. So the answer is letter C. Free body diagram. 9. The resultant of two concurrent forces is minimum when the angle between them is A 0 degree, B 90 degree, C 45 degree, D 180 degree. The answer is letter D 180 degree. 10. These are forces whose lines of action all pass through a common point. A. Collinear forces, B. couple, C. coplanar forces, D. concurrent forces. The answer is letter D. Concurrent forces. 11. The radial distance from the axis to the point of application of the force is called A. Radius vector, B. Lever arm, C. Normal, D. Displacement. The answer is letter B. Lever arm. 12. As the angle between the two concurrent forces decreases from 180 degrees, the resultant A. decreases, B. increases, C. unchanged, D. cannot be determined. The correct answer is letter B, increases. 13. The moment of inertia of a triangle with respect to the base is how many times its moment of inertia with respect to its centroidal axis. A 1/2, B 3, C 1/4, D 5. The answer is letter B, 3. 14. Moment of inertia is also called A. Moment of mass, B. Moment of center, C. Second moment of area, D. Moment of volume. The correct answer is letter C. Second moment of area. 15. The maximum number of components that a single force may be resolved into is A1, B2, C3, D4. The answer is letter B, 2. 16. What is the moment of inertia of a circle of radius r? A pi r to the 4th over 4, B pi r to the 4th over 12, C pi r to the 4th over 15, D pi r to the 4th over 16. The answer is letter A, pi r to the 4th over 4. 17. What is the standard acceleration due to gravitation force? A 32 feet per second squared, B 980 feet per second square, C 32 meter per second square, D 98 feet per second square. The answer is letter A, 32 feet per second square. Which of the following is not a vector quantity? A force, B distance, C weight, D velocity. The answer is letter B, distance. 19. 1 Newton is equivalent to A kilogram meter per second, B kilogram meter per second, C kilogram meter per second, D meter per second squared per kilogram. The answer is letter C, kilogram meter per second. 20. The moment of inertia of a rectangle with respect to the base is how many times its moment of inertia with respect to its centroidal axis? A2, B3, C4, D5. The answer is letter C, 4. Okay, so I think that's it for this video. Engineering Board Exam Review, GEAS or ESAS for Engineering Mechanics Statics. So abangan nyo na lang yung next upload ko for Engineering Board Exam Review for GEAS or ESAS. Okay? So sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.